Okay, just waiting for the slides. Thank you very much to thank you very much for the introduction. Thank you very much, Professor Gojabori and other organizers for inviting me. I'm very pleased indeed to speak to you about CODATA and about the data revolution. Thank you very much to Professor Taniguchi. You mentioned lots of points there that I think have a bearing on some of the things that CODATA is trying to do. And hopefully you'll see that in the presentation. You'll see the way in which we're responding to many of the developments which have been mentioned there. Just waiting for my presentation. While I'm waiting for the presentation to go up, I'll just mention that CODATA is the Committee on Data for Science and Technology of the International Council of Science. We're based in Paris, but we're an international organization. The three areas of our strategy, which I'll talk about to some extent in the presentation, are data policy. We advocate open data policies for research. Data science, so we have activities to explore the frontier issues of data science, and data education, or data training and capacity building. This looks a little bit strange. Yeah, there's clearly a delay. Can I have those 90 seconds back, please? Okay. Okay, so I'm going to talk about the data revolution and its implications. We've heard a lot about that already today. People have been discussing this and talking about it for some time. The first report there, Bits of Power, I think came out in 1999. There's the fourth paradigm report, which looked at data-intensive research, and more recently, the Riding the Wave report from an expert group of the European Commission. This provides some of the context of how does science and society adapt to the greater availability of data and the greater volume, velocity, and variety of data. I think the 3 V's should be used of our definition for big data. Veracity is something that we would like in big data, but it's not an inherent quality of big data, whereas volume, velocity, and variety are. So I'll go through some of these, provide some examples of data-intensive research and the way in which researchers are responding to it, and speak to some extent about the CODATA strategy. So the first report that I want to mention is the Science as an Open Enterprise report. The lead author was Geoffrey Bolton of the Royal Society, and he's now CODATA president. And that report analyzes the challenges presented by the way information technology has revolutionized research and suggests some responses. And it argues, above all, that responding to the data revolution is the challenge which faces science and research internationally, and that a big part of our response has to be open data, making the data available. It argues that the way in which science is conducted, because of the rise in the volume of data and the complexity of data, the reproducibility of research is being challenged. And our way to respond to that must be to make the data which underpins research findings available for verification. So this is an important argument there. Now, data is also an important resource for research. This is a quotation attributed to George Bernard Shaw about the way in which the reproduction of data is a wonderful resource for research. If you have an apple, and I have an apple, and we each exchange these apples, then you and I will still have an apple. But if you have an idea, and I have an idea, and we exchange these ideas, then each of us has 2 ideas. And this is the same, this is one of the fundamental principles of research and knowledge, and it's also one of the fundamental principles of data, and the reason why open data is an important principle for research in the big data era. Here's an example. I've just come back from the plenary meeting of the Group on Earth Observations in Mexico. And this is the executive director of that organization, which is an intergovernmental organization which promotes the sharing of Earth observation data, largely remote sensing data. In 2007 or 8, in 2008, the US government decided to make Landsat 7 data freely available. Previously, the US Geographical Survey had been selling those data. Undercharging, they sold 53 scenes a day. Now, with that data openly and freely available, 5,700 scenes a day are downloaded. The increase in use of those data is fantastic. It's increased exponentially. And the research being carried out using those data is being enabled by that openly and freely available data. The other thing is that the USGS was actually selling those data, undercharging to whom? Well, largely to other government agencies and to universities. So it was just money sort of being, state money being recycled. And so, for example, a Spanish deforestation study, undercharging that study would have cost 260 million euros. It wouldn't have been possible. So there was research happening which wasn't previously possible. And just by way of mentioning it, CODATA has recently produced a white paper on the value of data sharing, which outlines some of these arguments for the geo community on the benefits of freely and openly available data. Now, I need to stress very clearly, when we talk about open data, we use a definition which recognizes inherently that not inherently to the definition that not all data can or should be shared. There are limits, there are boundaries to open, and those boundaries are defined by privacy issues, legitimate commercial concerns, public interest, for example, security or the location of endangered species, etc., etc. So that's, when we say open data, we acknowledge that there are these limits. But the important point to stress is that data should be open by default. We put the onus on demonstrating that the data shouldn't be shared, rather than assuming, can you demonstrate that it should be shared? I think that's an important point to make. And also exploring these boundaries, identifying precisely what data can be shared and what data can't, is an important topic for policy and indeed an important topic for research. I'm going to quickly mention 2 reports which provide very useful examples of the use of big data and the data revolution in research and for policy and for society. The first is A World That Counts, which is a report from the UN Expert Advisory Group on the data revolution. And that argues that our response and our understanding of sustainable development needs to incorporate new data sources. And in particular, governmental statistical agencies need to modernize and adapt in the way that they work, using other forms of data. And it also highlights the issue about, which was mentioned in Professor Taniguchi's talk, about the gap in technology and in some cases skills between richer and poorer countries. Another examples, a report from the Open Data Institute and the global, what does GODAN stand for? It's the Global Open Data in Agriculture Network. How can we improve agriculture, food and nutrition with open data? Again, I just want to mention this report very, very quickly. It provides a host of case studies of specific research projects which have used open data to advance agriculture and nutrition in various countries, and is a useful source of reference for the benefits of big data and open data. Just going to provide two examples as well we've heard a lot about big data in genomics. Here's some examples of big data in social sciences. So Terra Populus, which is a project linking census data and household survey data with geographical data to look at the complex interactions of society with the environment. And similarly, I was going to ask, does this meeting have a Twitter hashtag? A Twitter hashtag. So often nowadays when we go to conferences, the conference will have a Twitter hashtag. And people will be able to tweet, oh, Hodson, what's he talking about? He doesn't make sense, yeah? And this sort of thing. People use Twitter and social media an awful lot, and it is a data set which can be used for certain types of research. Attitudinal research, responses to global events. So for example, there's this global data set of events, location, and tone. Twitter was used a great deal in the Haiti earthquake. Crowdsourced data was, for example, OpenStreetMap was used a great deal in response to the Nepal earthquake. There are data within these vast social media data sets which can be used for research and for real-world responses to events. Oh, what happened? As an example, the sort of work that CODATA is doing in this sort of area, we're very interested in the idea of smart cities or the use of big data in an urban context. We helped the International Social Science Council organize this year's World Social Science Fellows Seminar at the end of the year at the ICSU International Program Office for Urban Health and Wellbeing. And the sort of questions we ask of that sort of research are the following. So from a strategic point of view, from the idea of a data strategy, when looking at a research question into smart cities, into the way a city gathers data and responds to the information received through that data, are the data available? What policies are in place within that city? How may the data be integrated and analyzed and collected? What are the ethical implications? And what skills are required? So we have this meta approach to the study, to research in particular areas. And one of the areas that we're applying this, as I said, is in smart cities. And there you see an example of a Wordle which came from a seminar about data and smart cities. So I'm going to talk a little bit now about the CODATA strategy and some of our activities in areas of policy and training in data science. And by way of introduction to that, I want to try and explain our definition of data science, which requires me to read out that slightly long paragraph in the middle of the slide there. We argue through our analysis, through observing the way in which research is changing and the required response to the data revolution, we argue that contemporary research, particularly when addressing the most significant transdisciplinary research challenges, increasingly depends upon a range of issues relating to data. These issues include the principles and practice of open science, which I've mentioned, and research data management and curation, how we look after the data when we collect it. The development of a range of data platforms and infrastructures, the techniques of large-scale analysis, statistics, visualizations, modeling techniques, software development, data annotation, and the systematic study of this evolution of all those things we call research data science. So this is what a lot of CODATA task groups do. They do this meta-analysis on the way that research is changing due to big data and the data revolution. And we have a thing called the Data Science Journal, which is available on a new platform with Ubiquity Press as an open access journal, which is one of the ways in which we pursue that activity. So key issues: reproducibility in research, statistical and epistemological ethical issues in relation to big data, coordination of discipline vocabularies, and data integration and data strategies for international research programs. Those are key things which are on our agenda for the frontiers of data science. One of the ways, again, which we do this is through a conference which we organize every 2 years. That used to be the CODATA conference. In 2014, we organized it with the World Data System, which is another ICSU body, as Citation. And the next edition of that conference will be on 12th to 16th of September in Denver, Colorado, and tagged as International Data Week. And that brings together 3 organizations, CODATA, the World Data System, and the Research Data Alliance, which you might have heard about. Those are all international organizations which are trying to address these important data issues. So I'll work on data policies and data training, which I'll try and skip through very quickly. So I mentioned that we advance data policies, we promote and articulate the grounds for data policies. I mentioned the white paper that we produced recently for GEO. We have an International Data Policy Committee, and we recently produced a report on best practice in research data policies. Now, you're probably aware that a lot of funding agencies and increasingly research institutions and indeed some research journals now have data policies about data availability and about the terms and conditions under which data should be looked after. So we study those policies, and we produced a report which recommends the key important elements that those policies should contain. And we also work with CODATA members, most recently in Kenya, and with the Polish government on the development of their data policies. The work with Kenya came out of a workshop which we organized in August 2014. That was attended by the Kenyan Minister of Science and Technology, and he argued that it would be a good thing for international organizations to engage more with developing countries on open data issues to promote open data, and that the Jomo Kenyatta University of Agriculture and Technology should develop a center for excellence in open data, which is what they did, and now CODATA is working with that center on their data policy and on their activities. As I said, CODATA is part of the International Council of Science. We were asked to lead on a new initiative called Science International, which brings together 4 of the global organizations that coordinate scientific activity and represent scientists internationally. So the World Academy of Science, the International Academy Panel, the International Social Science Council, and the International Council of Science. This year's Science International meeting will be on the theme of big data and open data, and CODATA has been asked to present the policy document for that initiative. And we hope to follow that on with a capacity building activity, which will address these sort of issues. How do science systems, in the broadest sense, address the challenges of the data revolution, the challenges of big data, and addressing those challenges by promoting open data? So we've presented to the Ministry of Science and Technology in South Africa a programmatic roadmap. And we hope that with other international partners, will get funding to develop, to mobilize capacity for big data and open data in Southern Africa. And we argue that for a good science system governance, you need an open data forum, and to develop the open data policies which we've spoken about. Also, we have a blueprint taken from other countries for open and big data infrastructure roadmaps, training and skills initiatives, which we've developed, also to address the issue of incentives for open data, and as an essential part of this initiative it's important to have flagship co-designed data-intensive research projects which demonstrate the benefits of adapting to big data and open data in research. I'm going to, because of limited time, I'm going to skip through the stuff on data citation, and I'll talk about our training activities. So I mentioned data science and our definition of data science. Now, CODATA runs international training courses. In the last 18 months, we've run training courses on data science in Beijing, in Kenya, in Bangalore, and also in Jakarta. And interestingly, this work often works on a network effect, in that, for example, 2 students from the Indian Statistical Institute in Bangalore attended the Beijing workshop and then decided that they wanted to host one of the workshops in Bangalore. And similarly, 4 students from Jakarta in Indonesia attended some of those workshops and then organized a follow-on workshop in Jakarta. So this is how these things often work. You provide the skills, and then you train the trainers, and then they run a workshop in their country.
Yeah, thank you very much. Very interesting.
Can I finish 2 slides?
Yeah.
Yeah. Is that it? I don't think so. Okay. I just got 2 slides. I lost 90 seconds at the start. So we now have a program for research data science summer schools, based upon the model of the schools that are the workshops that we've done hitherto. And these address a broad research data curriculum. So the sort of things that I mentioned, which we argue are key skills for all researchers. So knowledge of open data, knowledge of the data policies, the ability to run large analyses on platforms like Hadoop, the use of R for statistics, the use of visualization packages. These are skills that researchers in all disciplines increasingly will need. We're working with a number of partners, software carpentry and data carpentry, which have teaching materials in each of these areas, with the Digital Curation Centre in the UK, which runs data management courses, and with international partners like CERN, like the Square Kilometre Array, which has also already been mentioned. There's just a slide on the curriculum, which you can consult afterwards. What I wanted to mention is that the first of these courses will be happening at the International Centre of Theoretical Physics in Trieste in August. They're hosting the course and providing accommodation and board for up to 120 students. We have funding from them and from TWOS and from other sources, including the Group on Earth Observation, for international travel for students, mostly from lower and middle income countries. And as I say, that course addresses those key issues in research data science and the adaptation of skills for all researchers to the challenges of big data, open data, and the data revolution. And we have the ambition to take that course on an international tour, much as we did with those previous workshops that I mentioned, and take it to various countries. So just to close up about that, just to mention some of the points about the CODATA activities. There's the Data Science Journal. There's the International Data Week next September. There's the Data Science Summer Schools, which I mentioned, which is happening next August. And the recent or forthcoming reports on the value of open data sharing, which we produce for GEO, legal issues related to data, which we'll release in Tokyo in March at the Research Data Alliance meeting, and we're doing some work on business models for sustainable data infrastructures with the OECD Global Science Forum. And thank you very much for your attention.
Thank you very much.